Hello friends, welcome once again to Mathematics Olympiad platform, and we have this question here which says simplify 2 raised to power 2 raised to power 2 raised to power 2 raised to power 0 Now from here we can, to simplify this, we first consider the exponent 2, the last 2, that is raising power 0. So that exponent is 2 raised to power 0. Anything raised to power 0, the identity of anything raised to power 0 is 1. So if we have 2 raised to power 0, it means is equal to 1. So since 2 raised to power 0 is 1, then what we now have is we have 2 raised to power 2 raised to power 2 and then raised to power 1. So from here we have 2 raised to power 4, because the 2 raised to power 2 raised to power 2 raised to power 1 will give us 2 raised to power 4, and that will give us 16. That's the answer to the first question. Now we have the second question. If m and n are the zeros to the function f of x equals x squared minus 11x plus 30, what is m plus n minus mn? So from here we know that the root of equation of the equation x squared minus 11x plus 30 is m plus n, m and n, where we have m plus n equals 11, the coefficient of x, and mn, that is m times n, equals 30. So we plug that in now. So where we have m plus n, if you put 11, then minus where we have mn, you put 30, we are going to have 11 minus 30, then which will give us minus 19, and that will be the answer. The third question says find the value of x if 2 raised to power x equals x raised to power 32. So we have, the first thing we are going to do is to multiply the exponents, both exponents, by 1 over x. So we multiply 2 raised to power x by 1 over x and x raised to power 32 by 1 over x. This is to eliminate the power x at the left side of equal sign. So we then have 2 raised to power x equals x raised to power 32. If we multiply both power by 1 over x, we have 2 raised to power x times 1 over x equals x raised to power 32 times 1 over x. So the x will cancel x at the left side of equal sign. So we have 2 left. So we now have 2 equals x raised to power 32 times 1 over x. So what we then do now is to multiply the 32 times the exponent 32 by 1 over x, which will give us 32 over x. So we have 2 equals x raised to power 32 over x. It then follows that since we now have 2 equals x raised to power 32 over x, we can multiply both powers by 1 over 32 to get rid of 32 as the exponent at the right side of the equal sign. So we have 2 raised to power 1 over 32 equals x raised to power 32 over x times 1 over 32. So we then have 2 raised to power 1 over 32 equals x raised to power 1 over x, because 32 will cancel out 32. So we have 1 over x left at the right side as the exponent of the value at the right side of equal sign. So the next thing we have here is we look at the exponent over 2, which is 1 over 32. We want to break it down further so that we can have equivalent values at both sides of the equal sign. So now if you multiply 2 by exponent 2 by exponent 1 over 64, in order to break it down to, so we have 2 raised to power 2 times 1 over 64 equals x raised to power 1 over x. So 2 raised to power 2 now will give us 4. That means we don't have that exponent 2 there again. We only have 1 over 64 left as the exponent on 4 now. So we now have 4 raised to power 1 over 64 equals x raised to power 1 over x. Then we do the same thing again. We reduce that 1 over 64 or multiply it by 2 again. So we have 4 raised to power 2 times 1 over 28 equals x raised to power 1 over x. Why did you put 1 over 28 there instead of 1 over 64? Because 2 times 1 over 28 will still give us 1 over 64. So 2 times 1 over 28 is the same thing as 1 over 64. So when you say 4 raised to power 1 over 64 equals x raised to power 1 over x, is the same thing as 4 raised to power 2 times 1 over 28 equals x raised to power 1 over x. So we have 4 raised to power 2 multiplied by 1 over 20 equals x raised to power 1 over x. So 4 raised to power 2 will give us 16. So we have 16 raised to power 1 over 128 equals x raised to power 1 over x. We do the same thing again, multiply by 2. So if we multiply by 2, we change 128 to 256 so that we can have the same value. That is 2 times 1 over 256 will give us 1 over 128. So we replace that 1 over 128 with 2 times 1 over 256. So we have 16 raised to power 2 times 1 over 256 equals x raised to power 1 over x. So we have 16 raised to power 2 times 1 over 256 equals x raised to power 1 over x. So 16 raised to power 2 will give us 256. That will now give us 256 raised to power 1 over 256 again, which equals x raised to power x, which means we now have the same equivalent value. We have equivalent values on both sides of equal sign, which means we can equate either the base or the exponents. So which means our x equals 256. So x equals 256. That is that for this third question. Then we go for the next question. So the next questions we have here will be the questions we are going to treat for the next class. We have 2 questions to be treated, and the first one says if 5 raised to power x plus 1 equals 100, find the value of 2 raised to power x. The second one says if p and q are the root of x squared minus 7x minus 3, what is the value of p squared minus 7p plus q squared minus 7q? Thank you. Till we meet next class, don't forget to subscribe and click notification and like button and share the video with your friends.